We are discussing mass spectrometry. What is even electron rule? This rule predicts the most likely sequence of ions. It states that an even electron species will not normally fragment into two odd electron species. Since the total energy of this product mixture would be too high. In preference, an ion will degrade to another ion and a neutral molecule. Successive losses of radicals are forbidden. Radical ions, being an odd electron species, undergo fragmentation by loss of radicals or even electron molecules. That means where B dot plus may be a molecular ion or fragment ion formed by loss of neutral molecule from the molecular ion. N2 and N3, these are neutral radicals. N1 and N4 are neutral molecules. Next is, what is nitrogen rule in mass spectrometry? Nitrogen rule. An organic compound containing an odd number of nitrogen atoms will have a molecular ion with an odd mass number, provided the other elements present are carbon, hydrogen, oxygen, sulfur, silicon, or halogens. Similarly, a molecule with even molecular weight contains either no nitrogen or an even number of nitrogen atoms. The nitrogen rule can be used as illustrated here because of the fact that nitrogen has an even atomic weight. And an odd valence, whereas all other elements encountered in mass spectrometry have either an even mass and an even valence or an odd mass and an odd valence. The inclusion of many common stable isotopes except 18 oxygen alters the use of nitrogen rule. Next is, what is McLefty rearrangement? In mass spectroscopy, McLefty rearrangement. Beta cleavage of a bond with gamma hydrogen rearranged to form a cation radical and a neutral molecule, and this is called McLefty rearrangement. This rearrangement is characteristic of compounds containing a gamma hydrogen with respect to a multiple bond. This ion undergoes McLefty rearrangement and this is the fragment ion formed. This is fragment ion formed plus neutral fragment, which is ethylene molecule. This is also called a neutral fragment with M by Z 28. So beta cleavage of a bond with gamma hydrogen, a rearrangement. This is gamma hydrogen. Gamma hydrogen rearrangement to form a cation radical. This is cation radical and a neutral molecule is called McLefty rearrangement. This happens in those compounds which contain a gamma hydrogen with respect to multiple bond. Now this is the functional group carbonyl, this is alpha carbon, this is beta carbon and this is gamma carbon, and the hydrogen attached to this gamma carbon is called gamma hydrogen. Next is, what is ortho effect? Molecular ion of methyl salicylate. Molecular ion of methyl salicylate undergoes a rapid loss of methyl alcohol through a 6-membered transition state to form a species whose M by Z is 120. This type of transition state is characteristic of benzoic acid and benzoate ester that has a ortho substituent bearing an alpha hydrogen, and this is called ortho effect. This is methyl salicylate. This is how it occurs. This is six-membered transition state, and it forms a species whose molecular weight is 120. This type of transition state, this is the transition state, this is characteristic of benzoic acid and benzoate ester that has a ortho substituent bearing an alpha hydrogen and is called ortho effect. Next topic is isotopic clusters. We are discussing the important terms which are useful in mass spectrometry, which is a very important and useful technique of structure elucidation. What are isotopic clusters? Many elements occur naturally as a mixture of isotopes. Isotopes of lighter mass predominate, this is to be remembered. Many elements, they occur naturally as mixture of isotopes, resulting in appearance of the second isotope, which is heavier one, in the molecular ion region of the mass spectrum. Thus, the presence of an element with chlorine, bromine or sulfur containing two or more isotopes of natural abundance leads to characteristic pattern of peaks, which is called isotopic clusters. Now, how to determine percentage composition of elements in a molecule? Natural abundance of isotopes of common elements, this we get in literature. It may be noted that in a molecule containing one carbon atom, the probability of being a 13 carbon is 1.108. Natural abundance of isotopes of common elements we encounter in literature. It may be noted that in a molecule containing one carbon atom, probability of isotope with mass 13 is 1.108%, and its probability of being a carbon with atomic weight 12 is 98.892%. Therefore, a molecule of methane will have a molecular ion which corresponds to 12CH4 and another corresponding to 13CH4, and their relative abundances are approximately 99:1. When more than one carbon atom is present in an ion, the probability of any one of these atoms being 13 carbon is found by using a binomial expression. This is binomial expression. When more than one carbon atom is present in an ion, probability of any one of these atoms being 13 carbon is found by this expression. A is percentage natural abundance of lighter isotope, and B is percentage natural abundance of heavier isotope. And N is number of carbon atoms. N is number of carbon atoms present in the ion. Thus, for an ion containing two carbon atoms, the expression becomes 99.89, 12 carbon plus 1.11, 13 carbon 2. So this is how we use binomial expression in mass spectrometry to determine percentage composition of elements in a molecule.